This series of lecture slides is going to look at audio hardware and connectivity in the context of multimedia sound production. So we'll be looking at sound capture devices, that is, devices that are able to take sound externally and record it through the computer system and typically to the hard disk as an audio file. So sound capture devices would include things like sound cards and external interfaces that can connect to the USB port on your computer, typically through a laptop system. The typical setups and applications that you would use these arrangements for. Some connectivity standards, specifically the different various types of connectors that you would get that you'd need to be able to connect from one device to another, and there are standards that have arisen, so-called de facto. De facto means standards by virtue of use. So de facto standards, connectors that one would use to connect these devices together. The difference is that one can achieve through connecting through either a line as opposed to a speaker system in terms of the outputs from one device to the other and the improvement on sound quality. And also the typical stereo connections that are made between a stereo pair left and right. So sound capture devices, sound cards. Creative Labs was one of the first companies really to create sound cards for the PCs in the early 90s. Prior to that, the only sound devices really was what you could hear out of the little tiny speaker at the front of the PC cabinet. And they have become, to the period right up to today, the de facto standard on PC, the Creative Labs. There are others, but they're the ones really that kind of led the field, if you like. They had their so-called Sound Blaster series of cards. The numbers there refer to the bits, the actual kind of connectivity aspects of the card, 16, 32-bit, and so on, 64-bit. They were the early so-called legacy cards, the ISA cards. These are things you plugged into the computer's motherboard. And then later on, the more capable PCI cards. You can also get onboard sound hardware. That is the device that handles the sound, converts the analog signal to digital and back again for sound output, is actually on the motherboard, on the actual main component board of the computer. And they're the kind of that's the less capable type of sound hardware. It's the sound hardware that's on the motherboard. And then we have external modules. Again, Sound Blaster has one called the Prodigy. There are others. And they provide an external device whereby you can connect to an external sound system. You still have to have something plugged into the motherboard, but it links, it kind of is tethered to a sound device module that's external. Another USB powered modules, again, one of the main companies out there is a company called M Audio, and they provide a whole range of device modules for various sound recording and sound production capabilities. Here's an example of a early, now legacy. Legacy in computer terms generally means it's out of date, but it might still be worth having. But this is an ISA sound card. But the important thing about this thing is got a line in, a microphone in, so you can take a signal in here and a signal in here, and a line out and a speaker out. It's also got this here which is used for the game port, so typically you connect a game controller, joystick, but also this is where you connect your MIDI device, and that will provide MIDI in and MIDI out signals. So you could get your external MIDI keyboard connected to this device here via this port, and the signals from the MIDI keyboard will be taken into the audio software and then back out again to the MIDI keyboard or controller that was generating the sound. Generally, these different inputs have different line sensitivities. So the line in tends to be less sensitive than the microphone in, and the line out tends to have less output than the speaker out. But the important thing about line in and line out in any audio system is it has what's called a flat signal. There are no equalizations applied to it as you would do in your graphic equalizer that you have on your music device, where you can raise the bass and treble and mid-range and so forth, and you get kind of a waveform effect on this audio signal. Line in, line out give you a flat signal, so they're ideal inputs and outputs to connect to other devices because you're not introducing any equalization, and that's a really important thing in audio recording systems. Here's an example of a PCI sound card. It's got very similar connectivity, but in this card, this device, the manufacturer started to color code the inputs and outputs to help mainly domestic consumers connect stuff up. Made it easier for them to recognize that blue connects to blue and green connects to green and so forth. And those colors in themselves have become standards now. So the green always is indicated as the speaker out connector that one would use to connect to external speakers and so on. And this is an example of the Sound Blaster Audigy. So we have a more sophisticated card here with a range of connectivity out to MIDI in, MIDI out and other audio connectors here that would connect to your external devices. There is also, importantly, a digital input and output as well on this device, which will give you a much higher quality signal than having it change between audio and digital and back again. Just to illustrate the idea of having a flat signal as opposed to having a waveform signal in the context of speakers and line inputs and outputs, then this would represent the speaker output with its various modifications to the bass, middle and treble frequencies. And so speaker output signal has volume and bass treble modifications, and therefore it has a poorer quality for recording, whereas the line connectors give a flat signal. So the idea, the word flat, comes from the fact that actually the signal waveform is flat, and so there's no amplification or gain, as it's called, or equalization, modifications of bass, treble and mid-range and so on. Here's some examples of connectivity. We've got our phone RCA connectors here, often referred to as phono connectors. The red indicates it's the right-hand channel, the white indicates it's the left-hand channel for stereo, and here's a stereo jack, 3.5 stereo jack. This mono jack here, so this is just a single mono signal. It doesn't have a stereo capability, but it's typically used for things like connecting electric guitars into external sound modules, and also connecting speakers that have single mono inputs, but you have two, one for the left, one for the right hand channel and so on. This is a so-called XLR connector that's most associated with microphone connections. It also appears on some more sophisticated speaker connectors, so you can connect your amplification via your XLR socket to your speaker. And here's an example of a MIDI connector where you've got the MIDI connector to the device we saw earlier for the sound card gain ports, and MIDI in and MIDI out individual connectors to the various devices. So connecting for stereo, then typically you'd have a jack plug with insulated segments, and the tip would be the right hand channel, then we'd have the middle section as the left hand channel, and this longer section here would be a common earth. So the red line in this case denotes the right hand channel, and the blue line denotes the left hand channel, and the black lines where they join there denote the common earth, as it's called, to enable the other side of the left and right hand channels. So together we get a stereo input to our connectors here and back again. And there are various connection alternatives to that. This is an example of a 3-pin XLR microphone connector, and again we've got a common earth connection via the black line and our right hand channel in red and our left hand channel in blue. In summary then, we've seen some examples of internal sound capture devices. We've had a look at various standard connectors, for example phono, RCA phono, jack and XLR. We've seen that line output has a flat signal compared with speaker output, and this is the preferred connection to external recording devices or system. And we also had a look at the wiring required to achieve stereo connectivity between devices, i.e. left and right stereo pair. This concludes the first lecture on audio devices and connectivity.